Question number 3, given the function f of x, we have to calculate the integral from 1 to 3. So let's go to a calculator page. First, we can define the function f1 of x is equal to, let's have a look again, x3 minus 3x2 minus 4x. Done. Okay, so that's okay. Now go to the template, choose this one. The lower limit is 1, the upper limit is 3, and then the function is our function f1 of x. Dx minus 22. And remember, an integral can be negative, so that's okay. The answer would be minus 22. B, calculate the area bounded by the curve of f of x and the x-axis. Okay, so in this case, it would be a good idea to have a look at the function to see where it crosses the x-axis to see how it looks like. So let's add a graph page. Go up, press enter to draw the graph. We can zoom out so we see the little part down here, the minimum. So how about zoom out once, and then we can do zoom and do a box zoom. So we go from here to here. Okay, and then escape to go out of the zoom mode, and we can place the function here. So what was the question? In B, they asked us to calculate the area bounded by the curve of f of x and the x-axis. Okay, so the total area would be this area here and also this area, but we need the limits because we cannot just if we do the calculation in one step just like we did here, we get minus 22. And that's not the area, because this is going to be positive, this area, and this is going to be negative. So we have to do it in two steps. First this part, and then add it to this part. So let's find out what the limits are. So analyze 0 to the left and to the right. Here's 1, 0. I think the 0 would be in the origin, but just to be sure, let's confirm that. That's the another limit. The last one would be over here. So x is equal to 4. Okay, so let's find out what the integral is for the function between minus 1 and 0, and then between 0 and 4. Okay, because here you have x is equal to 0, x is equal to 4. So first from minus 1 to 0, you can just go up, press enter, and then change the limits. Upper limit was 0, the lower was minus 1. Okay, so 3 over 4, which is 0.75. The second part would be between, well, the upper limit was 4, the lower limit was 0, minus 32. And this is because this is below the x-axis. If we're talking about area, it's the same number but positive. Okay, so the area is 32 for that part, and up here we had 0.75. So the total area would be 32 plus 0.75, which would be 32.75. And since we don't know if it's in centimeters, meters, we're just going to write unit squared. Okay. Then they give us this formula. The area bounded by the graphs of two functions is given by the following formula. So between a and b, where the two functions cross, the area between these two functions you can find out with this formula. So the second function, g of x is equal to minus x2 plus 2x, is introduced in the same coordinate system. So let's go here and plot that function. So g of x is equal to minus x2 plus 2x, minus x2 plus 2x. It looks like that. Put it down here. Now we see that we have one area here, okay, where this function f1 is the upper function, and this one f2 of x is the lower function. Here we have another area to the right, where f2 of x is the upper function, f1 of x is the lower function. So what are they asking for? Which one of these are we working out? Find the area of the region bounded by the graphs of the two functions in the coordinate system where x is greater than 0. So they want us to find this part where x is positive or greater than 0. So the limits would be 0. And what's the x value for this point? That's the question. So let's find out the intersection function, left, right. There we go. So when x is 3.65, they intersect here in this point. So between 0 and 3.65, and then the question is which one is the upper, which one is the lower. It doesn't really matter because we know that we're looking for an area, and if we mix them up, if we have the upper function as a lower function and vice versa, it doesn't matter because we get a negative or positive result, but we're just going to look at the numbers. Okay, so let's find the integral from 0 to 3.65, right? That was the upper limit. And let's see, which one is the upper one? Okay, so it's f2, the red one. That's the upper function. f2 of x minus f1 of x dx. And then the answer is 28.0133. And they want us to answer, did they say anything? No, they didn't say anything. So we'll choose one decimal. So 28.0. And since it's area, we don't know if it's centimeters, decimeters, meters. We're just going to answer in units squared. And here you have the lower limit, upper limit. So if we would have put, for example, f of x minus g of x, the answer would have been minus 28. And then we say since it's an area, it's positive, so 28. So this is not a problem. Last question. The volume of a solid of a revolution that revolves around the x-axis between x is equal to a and x is equal to b is given by the formula. Okay, so now the function f of x, the first function, revolves around the x-axis, creating kind of a cone or volume of solid of revolution. So we have to find the volume of this cone-shaped thing. Let's have a look at the graph again. So this function is rotating around the x-axis. Okay, so the lower limit is 0, the upper limit is 3. We basically just have to use the formula in a calculator page. So let's go back here. We have the function f1 defined already. So let's do this formula. It begins with pi. Where do we find pi? Let's go into this. And here we have pi. Just press enter. Pi times, and then the integral. Let's go to the template, choose this one. Lower limit 0, upper limit 3. Let's double check that. It's from 0 to 3. And then we take the function. Our function is f1 of x, and then square it, okay? So let's go down here, f1 of x, and then the function within brackets, because we're going to square the whole thing. So to the power of 2. And then dx, since x is the variable. Now, if we look at the formula again, pi times the integral from a to b, 0 to 3, of the function squared. So this is it. We press enter, and the volume is this. Now this looks a little bit weird because it has pi in the answer. So that's just because pi is, if we want the answer to be exact, we have to keep it like this. They want us to answer in a certain format. Give your answer correct to 2 decimal places. So let's find out what this is more or less. This is 823.187. They wanted 2 decimal places, so it's going to be 19 because we have a 7 here. So 823.19, and since it's a volume, we don't know if it's centimeters or decimeters or meters. We're just going to write unit cubed, or unit to the power of 3.